Hello, everyone, and thank you for joining us today. Let's review a few things and we'll get started. First, if you need to get our attention during the presentation, please use the chat box on your control panel to send us a message. And if anyone could test that out for me right now and just say hello, I would appreciate it. Okay, thanks. Looks like we're working. Okay, and next we'll have time for questions at the end, so you can either submit those as we go if you have questions, or you can save them for the closing. And finally, I'd like to introduce you to our presenter for today. Matt Williamson is a professional engineer with nearly 30 years of process engineering and project management experience. Matt has been published multiple times in magazines and is an internationally recognized expert on combustible dusts and related regulations. He's led several projects for clients to conduct post-disaster explosion investigations, implement plant recovery strategies, develop process safety management redesigns, and develop facility PSM policies and procedures. As a leader at ADS, Matt guides a team of engineers on a variety of process development and improvement projects in the food, feed, bioscience, and consumer product industries. Matt earned a degree in chemical engineering from the University of Kentucky, is a licensed professional engineer, and is a member of the American Oil Chemists Society. And with that, I will turn things over to Matt.
Okay, thank you, Courtney. This presentation is a follow-up to a presentation that I gave last year that introduced the idea of a DHA. And in this presentation, I'm taking it to that next step where I want to talk about what needs to happen during the DHA, what needs to be included, and what things you can do in follow-up to that DHA and taking it to that next step. In the picture here, you see of course, imperial sugar, one of the major incidents that sparked all of this back in 2008. So if you're not familiar with NFPA 652, this was a new standard that was issued by NFPA in 2015 in September, and it is meant to establish an overall hierarchy and to consolidate some of those rules that were inconsistent amongst all of the various industry-specific standards that were out there, such as NFPA 61 for the oil seeds and grain industries, or NFPA 654, NFPA 664, and so on, that covered different industries. So under 652, this is the overarching umbrella that covers everything. Anyone that creates or handles combustible dust. So the one new thing, and really the only new thing that 652 created, other than cross-linking all of those standards, is it created something called the DHA, or Dust Hazard Analysis, very similar, if you're familiar with process safety management, to a PHA. It uses a similar format, but there are a few differences, and we'll go through those here. A DHA is, as I mentioned, is required for all facilities that handle combustible dust. It is retroactive. So regardless of the age of your facility, you have to have a DHA in place. And the deadline that was established when NFPA issued this standard back in 2015 was for September of this year. In other words, next month. Fortunately for many of you, I know we have a lot of individuals on this in this conference who are from the grain and food industries. In 2017, September of 2017, NFPA 661 was reissued, referenced 652 and the DHA requirement, and reset the clock for those particular industries, gave another essentially 2 years by restarting the clock last year. So those facilities have now until September of 2020. That is to have a DHA in place with an implementation plan. That does not mean that you have to have implemented your implementation plan by that time. It means you have to have a plan in place. So what is included in a DHA? First of all, you need to have data that describes the dust that you're dealing with, or evidence that it is non-combustible. So if you have a material, you're not sure if it's combustible, you get that tested and find out that it is not combustible in the form that you have it, you now have a document that shows that it is non-combustible, and that concludes that dust. However, once you find that your dust has a KST value, the first value that you would test, now you know that you are dealing with a potentially combustible dust. And you have to put the DHA in place for that dust. So I described here a number of tests that we would recommend. There are a few other tests that are more specific. I would say these 6 are the ones that you should always have. And I'll go into more detail about each one of those. You also need to identify the areas of your facility that handle these materials. Where are they concentrated, particularly around dust collection filters, filter receivers, spray dryers? These are the areas where these dusts are concentrated. What are the credible ignition sources? What are the mechanisms of suspension of this material? What are the safe operating ranges of that equipment? These are all the things you need to document. Then you'll look at your existing protection equipment. What do you have in place? Where do you have gaps? Where do you have the potential to propagate an explosion from one part of the facility to another? Because the primary incidence will be of damage will occur when you propagate an explosion. So you'll have a small explosion in a dust collector, and if it spreads, it's allowed to travel down the ductwork to a blower that has an inlet air filter. This inlet air filter will let that explosion travel outward into potentially a room that may have a layer of dust, and that entire room can go up into an explosion as a secondary explosion. And that's the primary thing that we're looking for. How do we prevent secondary explosions? And then at the end of this, you need to develop an implementation plan. And it's that plan that is key. That's what you have to have in place by next month if you are not a grain and food facility, by 2020 if you are. So here's an example of an incident that defies some of those rules around combustible dust. And what you'll see here is a corn silo that gave way. And there was actually, I believe there was a venting issue in this particular silo. This is whole corn that in a transloading facility in Indiana, where the silo was collapsing on top of a truck loadout area. And what you note is that this is outside. And we normally don't worry about, we'll often dismiss the combustible dust problems when they occur outdoors. Well, the reality is you may not have an explosion as a result of because you don't have containment. However, you are still susceptible to having flash fires, as this video will demonstrate. So here's where you see the silo beginning to collapse, and somebody here taking a video, probably on their cell phone, and they clearly have no idea what is about to happen. They think they're a safe distance away, and what can go wrong? So it's certainly an interesting thing to watch. You see the corn dust beginning to fall out of the seams on this silo. In a moment, you'll see the whole, there it goes. And boom. With no containment at all, that was a flash fire. Okay, if that had occurred inside of a building, that would have been a massive explosion that may have taken that building down and potentially killed anyone that was in it. And this photographer was lucky that this flash fire didn't reach him as far away as he was. I just find that an interesting video. Within the DHA process, the first thing you need to do is define your dusts. So first, identify how many dusts you have in your facility. What are the different dusts and what differentiates one dust from another? The things that differentiate dust are not just the source of the dust. So certainly corn dust is different than soy dust, it's different than sugar. But even within those, differences in the moisture content, differences in, so for example, in corn, you may have a difference in the starch content of freshly dried gluten versus gluten meal downstream in the process. You'll find they have different dust characteristics. Differences in particle size distribution will change the dust characteristics, and that's key. The next thing you need to do is outline the hazards in your process, that is, identify all of the nodes or pieces of equipment that handle these materials. You conduct a DHA review meeting at your site. Prioritize those hazards based on likelihood of an event. Create the implementation plan, and then choose, design, and implement those solutions. And we'll talk more about each one of these. So first of all, define your dusts. Not all dusts are the same. And you need to identify all of those different sources and different types, focus on the greater hazards. Okay, a greater hazard will come from a smaller particle size and a drier material. What I generally recommend that you do is test your dust. Okay, don't rely on literature to tell you what the explosion hazards of your dust are, because whoever put that data together in the literature isn't familiar with your dust. Okay, particularly if you are processing, grinding, drying, doing any of these things with your material is different than what is in literature. However, if you are bringing in a raw material and that raw material that you receive is the combustible dust, then it really falls upon your supplier to provide that data, because one of the requirements of NFPA 652 is that the dust data must be included on the SDS. So in other words, they have to provide you with that information. And conversely, if you are providing combustible dust containing materials to your own customers, you need to have this data defined on your product and included in the SDS. So what does this sampling take? I would recommend that you sample at the places where you concentrate your materials. If you can get your samples from a dust collector, that's best. If you cannot, then you'll want to have the lab do something a little different. So first of all, you're going to need about 2 liters is what I would generally recommend to get all of the testing done that you need. And now the testing labs, they'll say, well, I need so many grams for this test and so many grams for that test, and then they'll inconveniently say, I need so many milliliters of that. So they mix and match volumes and weights. Really about 2 liters is what you need. And I've generally found that this costs $3,500-ish per sample to get all of the basic tests done. Okay, now there may be some additional testing that you may want based on your specific requirements that would be over and above that. Typically, I find that around $3,500. You need to have a qualified lab do this. What I mean by this as received comment, there are ASTM standards for this testing that if you don't tell them otherwise, they are going to grind and dry your sample, which means that they're going to take that and turn it into an even greater hazard and then test it. Well, if you really want to know if the material that maybe you're packing on a packing line is combustible or not, or how hazardous is it in the condition that you're handling it, then you want to have them test it as received. Because the first test they'll do is a go, no go analysis. And if it turns out that your material is really just too wet to combust during that packing operation, you want it to stop right there, because then you don't need to carry that any farther. Because if you just hand them that sample and let them go, they're going to dry it, and they're going to make sure that it's combustible. So it's in your best interest to make sure that it's marked as received and that they do that go, no go analysis. However, if you want to test the worst case and make sure that you're doing a worst case analysis and you can't get material from a dust collector, you have to draw it from the stream somewhere else, then by all means have them go ahead and grind and dry it. So the first batch of testing, all of them will include this. These are the basics, your KST, PMAX, DPDT. These three things go together. They'll come in a single test package. KST is a measure of your explosion severity. It tells you how big of a boom will your dust make if it explodes. Okay, and it's the rate of pressure rise divided by a fixed volume or per unit surface area. And it is used primarily in the sizing of explosion vents. You'll also get a PMAX, that's the maximum pressure rise that can be developed during an explosion. And you can, as an option, design your equipment to contain an explosion. In the grain and food industries, that's generally not done. It's just impractical to design a vessel to hold 150 psi of pressure just to contain an explosion. But if you're over in some other industries like the oil and gas industry, they do that all the time. So what works for one industry may not necessarily work for another. The PDT is really, that's the rate of pressure rise. That tells you, that's an indication of how fast that the explosion will spread. It gives you an idea on detection equipment exactly how much of a response time you need or how far downstream before you put in an isolation device or a detection device. Other three tests that I personally recommend, one is minimum explosible concentration. That's how much, that's like looking at the LEL of a flammable vapor. Okay, so it is an option for you to try to run or operate your process below the minimum explosible concentration. If you can keep the quantity of dust in the equipment below that minimum explosible concentration, you don't have to worry. If you only get a cup full of dust once a month and it's never going to hit the explosible concentration, you're done. You don't need to worry about it. There is another end to this. You can operate above the explosible concentration where you don't have enough oxygen. Then it gets into limiting oxygen concentration, which is another thing. Minimum ignition energy is critical. You must have your minimum ignition energy. Quite frankly, this test is as important as the KST. There are specific standards that call out the minimum ignition energy as an exception to certain rules. And this is what tells you how sensitive your dust is to ignition. And if you have a minimum ignition energy below 50 millijoules, that is a critical cutoff point that is called out in NFPA 77 on static electricity. If you are below 50 millijoules, you need to pay particular attention to your bonding and grounding. Down around 25, 30 millijoules is what a human can generate as a spark. In other words, your personnel can be the ignition source to trigger an explosion if you have an ignition energy down in that range. And there are a lot of materials down in that 5 to 10 range that are particularly hazardous. Another one that I recommend, minimum ignition temperature. I generally always recommend this for a layer. It's the minimum ignition temperature for a dust layer determines the electrical insulation class, where you have to keep the surface of your motors, your lights, below a certain temperature, or it could spark a fire, ignite the dust layer that can accumulate on it. I generally only do MIT for a cloud in the event that you're dealing with something like a spray dryer and you're purposefully concentrating a cloud of dust under temperature. I don't always recommend that particular test. So here you see a table that is readily available. Actually, this is lifted right out of one of the old NFPA standards, and you'll see listed on there a number of combustible dust, common combustible dust, and some typical data. However, what I really want to point out on this is where I'm saying don't trust the literature, because even a source as reliable as NFPA is quoting something that you'll see came from the U.S. Bureau of Mines in 1961. Now, first off, what does the U.S. Bureau of Mines know about your dust, your flour, your corn dust? Okay, they don't know anything about it. Secondly, 1961, the testing standards were completely different back then. This data is completely irrelevant as a result of that. So that's what I would caution you against. So, as I mentioned, in the next step, you need to outline your hazards. That is, define the nodes. Where do you have equipment that is handling this material? Identify the free path of an explosion or travel from one piece of equipment to the next, or worst of all, to the outside. Identify your existing explosion protection and isolation equipment, and measure your indoor dust accumulations in your process areas and your packing rooms. Where I tend to find problems here are in those packing rooms. They're notorious for this. Different standards quote different levels of allowable dust accumulation, so this gets very inconsistent and it gets very confusing. Some standards will say 1/8 of an inch, other standards will say 1/32 of an inch, and another standard yet says enough dust to obscure the color of the floor. So it really doesn't take much to reach this point. And they'll also point to things like 5% of the area of the room. Then you conduct the DHA. At the facility, this is just a list of some of the people that need to be involved in the DHA. You need to review each node for the likelihood based on having all the sides of that pentagram. But keep in mind, as I showed in the video, if you don't have all the sides of that pentagram, you may not have an explosion, but you can still have a flash fire. Document your recommendations for mitigation and potential explosions. They're spread to secondary explosions. That's the key thing that you need to have. Here's an excerpt. I know you can't read this. This is just an excerpt from typical DHA that we conduct here at ADF Engineering. And the key thing that I like to point out is this column where we call out the likelihood of an ignition. That's really going to be the key thing that determines the prioritization, okay, when it comes time to put together an implementation plan. Those things, we tend to go 1 to 5, where 5 is the worst. Others may go 5 to 1, where 1 is the worst. However that's done, you need to prioritize these things, and likelihood is really the only thing you're looking at. When you do a PHA, conversely, for flammable liquids, flammable vapors, you'll find other columns here such as severity and detectability. Well, those things are consistent. They're always the same. We're always talking about dust in a DHA. So we eliminate those columns and we really just focus on the likelihood. So then you develop your written implementation plan. that spells out all of the things that you found during your DHA, and those may include follow-ups or studies for further analysis. You need to have an owner named for that. That is a person, not just a department, a person who owns that follow-up, and a timeline. Those are the things that OSHA will be looking for if they come into your facility to do an audit. Oh, and by the way, OSHA is in fact doing random audits. Okay, they have for several years now have been doing random audits based on their national emphasis program that they issued in 2008. And after September of this year, that's going to step up because there's a new standard in place. And they're already quoting this standard, and they are fining companies based on the general duty clause. OSHA themselves, they have no intention now, they've given up on the idea of generating their own combustible dust standard. They started one several years ago. They gave up. They recognized that they don't have the funding or the resources to put that together. They've decided to leave that to NFPA, and they are citing based on NFPA as under the general duty clause. So first of all, you need to conduct an engineering investigation of those high-risk areas that are found during the DHA to determine the best options. One thing I don't recommend that you do is go straight to a vendor. Okay, the problem with going straight to a vendor is they may be biased, and even if they have good intent, you always have in the back of your mind that, hey, they're just trying to sell me a piece of equipment. Well, you bypass that. You go to a third-party engineering firm who can help you identify where that equipment may be necessary and where you may have another alternative. Other alternatives include such things as reducing your relief pressure with venting and suppression. It may include inerting. Limiting oxygen concentration is an option that you have, and it works in a number of cases. Looking at weak roof designs in place of adding explosion panels on a silo. Housekeeping eliminates a lot of these particular needs, especially when it comes down to your electrical area classifications, because one of the most expensive things that can come out of a DHA is finding out that an existing facility needs to be Class 2, Group G, Division 1 or 2. And we often find that to be the case. But housekeeping can usually get you out of that, or at least take you from Division 1 to Division 2. So that's very, very important. You see in the picture here, this is a facility that we audited that has a lot of those issues that need to be addressed. So NFPA 69 is a good source for finding some of those alternative solutions, but some of those solutions that may involve some equipment, and an engineering firm can help you determine what those best options are. Is it best to put in a chemical isolation system? Well, it may be, those are expensive, but that may be your best option if your ductwork doesn't have the length required for a passive isolation, which would be significantly less expensive. Are flameless vents an option when you have a dust collector that's indoors? Yes, it can be. Those are the kind of things you need to evaluate. Inert atmospheres, if it's an external outside tank, that's great. If it's internal, that creates its own problems. So you need to deal with that as well. Proper explosion venting, containment, all of these things are other options that may be good solutions as well. But sometimes it is necessary to have those explosion vent panels added, to have those suppression bottles added, and a proper engineering firm can help you get aligned with, hey, what are some of the best choices for that kind of thing? How many suppression bottles do we need? once you're at the point where you've determined that chemical suppression, chemical isolation is necessary, that's when we need to engage some of these vendors that deal with these things. Isolation is something that generally comes up at every DHA because this is what historically has been the most neglected part of this. The most common isolation device is actually just a rotary valve, but NFPA calls out a particular type of rotary valve. It has to have 6 or 8 veins or more. It needs to have tight clearances that cannot be a flexible, like a rubber tip or a brush tip. It has to be a metal tip, has to have a clearance of 0.2 millimeters. Can't even see that. That is so tight. But that's the requirement to use that as an isolation device. What's more is you have to have an annual program to inspect those clearances to make sure that it hasn't worn. So it's not just a rotary valve. It's a rotary valve plus. Isolation devices that are out there, the flat valves are very, very popular, especially on pneumatic conveying lines. And a lot of people think the pneumatic conveying lines aren't a problem, but they are. A lot of the problems can occur in a conveying line. If you're going up to a filter receiver, if you have an explosion in that filter receiver, the path of least resistance is back through that pneumatic conveying line. And if there's nothing to stop it, it will not go back to your silo because of the rotary valve or whatever's feeding it. It will go out the blower. It will go out your air system through the filter, the air filter, which is often found right in the middle of the room where your personnel are. And you can turn that into a flamethrower in the event of an explosion. So this is where a flat valve is a very inexpensive device that can be used to stop that and protect your personnel. There's a company out there making a pinch valve specifically for pneumatic conveying lines. It's a nice piece of equipment. It's a little expensive, though. So in conclusion, the first step of this is to make sure you understand what dusts you have, what differentiates one dust from another. There's upstream of a mill and downstream of a mill. Those are 2 different dusts. You need to understand your risks, perform a DHA, document this. If you're a grain and food facility, that includes pet food and animal feed, by the way, you have until September of 2020. If you are not a food facility, if you are making something that is pharmaceutical, or if you are making something that is industrial, like industrial grade starch, your deadline is next month. It's a month away. You need to then follow up and implement your mitigation plan specific to your individual needs. Not everything has to be expensive, so have things looked at by an engineering firm who knows what they're looking at. So with that, if there are any questions.
Okay, like Matt said, if you have any questions, please add them now. We'll give everyone a couple seconds to fill in. It looks like we have a couple here. The first one, Matt, is what is a typical dollar amount for a DHA on a mid-sized facility?
Well, the cost of the DHA is going to depend on a couple things. So first of all, there's travel costs, and that's just a matter of how far away is your DHA provider from where you are. The next part of that is the size and complexity of your facility. So if you just have a handful of nodes and your nearby no more than 2 or 3 dusts, you're probably in the range of $10,000 to $15,000 to have the DHA completed. If you're a larger facility, like an oil seed, a soybean crush facility, for example, you're going to deal with quite a few nodes. It's a large facility. You're going to be up in the $20,000 to $25,000 range. The cheapest ones, if you're a little facility that just has 1 or 2 dusts, yeah, you'll be easily done with them, about 10,000 or so, not including the cost of the dust testing. As you recall, you need to have your dust tested first, about $3,500 a sample.
Okay, thanks, Matt. And then looks like we only have one other question right now, and that is, what if we're not done by the deadline?
If you're not done by the deadline, that's just a matter of the risk that you're taking on. So, you know, if OSHA's not knocking on your door, you know, you have until they do. The risk is if OSHA chooses you for a random audit, or even worse, if you have an incident. If you have an incident, OSHA is going to come knocking, and the first thing they're going to ask you is for your DHA. If you don't have it, there's where you're going to have the problem.
Okay, and we have one more question here. Assuming OSHA's 29 CFR 1910 is OSHA's law in terms of combustible dust, I haven't found any reference to it.
No, and you won't. They have not called any particular NFPA standards out this way, and OSHA hasn't done an update since 652 yet. They are waiting till this deadline. Okay, so as I mentioned, OSHA is not going to try to generate a standard of their own, but this is what they're going to be using as their standard for their national emphasis program. And the guideline is actually the NEP, the National Emphasis Program that was issued in 2008. And that's what spells out the nature of their audits and what they have held to.
Okay. And it looks like we have a couple more here coming in. Is the new release of NFPA 652, the 2019 edition, out yet?
I have not seen it. It is possible, and it may be coming out soon. I personally have not seen it. Based on what I saw with 61, if it's saying that 2020 is a new date, I would not be surprised, because I know some people who are on the board of NFPA 652, and they have hinted to me that they're going to push that out. But I don't know that 2020 is necessarily going to be that date. NFPA 61 calls out 2020 as that date for specific industries. There is some indication that they are going to move that date out, though. So I would not be surprised if they do, in fact, turn around and give me that.
Okay, thanks for clearing that up. Looks like one last question, but feel free to keep them coming if you have more. When testing a sample of dust, you mentioned that the dust should be tested as received. Are there certain times of the year when that sample should be collected, and how should it be collected?
The only reference to the time of year is if humidity is a factor at your facility, and I would leave that up to the individual facility to determine is it going to be drier in a certain part of the year than another part of the year. If your dust is going to be drier in the winter, yes, it could be a higher risk. I would agree with that. How should it be collected? You want to try to get as best a representative sample as you can. That is, collect a large amount of material from a dust collector, ideally, and then sample from that larger collection.
Okay.
With something like a sample thief. That would be ideal, if that's feasible.
Okay, well, it looks like we don't have any more questions. If you think of anything, feel free to reach out to Matt, or you can reach us through our website, adfengineering.com. We have a contact area where you can send us questions. And then another thing we didn't point out earlier, on your control panel, you'll see a couple of handouts there. One is the DHA guide, which is pretty much an infographic telling you the parts of the DHA you'll need to consider. And then the other one is a checklist to see if you're required to participate in some way in NFPA 652. So you can check those out. You can get in touch with us. You should have an email from the original invitation you got. You can reply to that. It'll come to me, Courtney. or you can reach out to Matt. And if there's nothing else, I think we're done here. Thank you all very much for attending, and we hope to hear from you. Okay. All right. Thanks, everyone. Have a good day.